In 2012, 3 scientists at Liverpool John Moores University in England sat down to answer a question that nobody had ever formally asked. How much gas came out of dinosaurs? This was not a joke or a bet lost at a faculty party. This was a legitimate research project that resulted in a peer-reviewed paper published in the journal Current Biology, one of the most respected biology journals in the world. The paper was titled, "Could methane produced by sauropod dinosaurs have helped drive Mesozoic climate warmth?" That is the academic way of asking whether dinosaur farts change the weather. Here is the thing. The answer was yes, probably. But before we get into what they found, we need to understand why anyone would bother calculating dinosaur gas output in the first place. The lead researcher, Dr. David Wilkinson, was studying sauropod ecology. Sauropods were the long-necked dinosaurs like Brachiosaurus, Apatosaurus, and Diplodocus. They looked like they were designed by a committee that had never seen an animal before but had access to unlimited neck material. These dinosaurs were enormous. A medium-sized sauropod weighed around 20,000 kilograms, which is 44,000 pounds. That is roughly the weight of 4 African elephants stacked on top of each other, and it is not something elephants enjoy. They ate plants constantly, all day, every day for about 150 million years. Now here is where the science gets interesting. Modern plant-eating animals like cows, sheep and goats produce methane as a byproduct of digestion. This is not a design flaw, it is how the process works. The bacteria in their guts break down tough plant material, and one of the waste products is methane gas. Cows today produce somewhere between 50 and 100 million tons of methane every year. This is enough that climate scientists actually track it. Livestock methane is a measurable contributor to greenhouse gas emissions. There are entire research programs dedicated to making cows less gassy. So, Dr. Wilkinson had a thought. If cows produce that much methane and cows weigh about 1,000 pounds, what about a dinosaur that weighed 44,000 pounds and also ate plants? He teamed up with a methane expert named Nisbet at the University of London and a colleague named Graham Ruxton from the University of St Andrews in Scotland. Together they built a mathematical model. The model was based on existing research about how methane production scales with body size in modern animals. Bigger animals produce more methane. This relationship is predictable enough that you can write equations about it. They estimated that sauropods lived in population densities of roughly 10 animals per square kilometre of vegetated land. They assumed about half of Earth's land surface was suitable habitat during the Mesozoic era. They plugged in the numbers, and when the result came back, Dr. Wilkinson said he did not believe it. 520 million tons of methane per year. To put that in perspective, all modern methane sources combined, both natural and man-made, produce roughly 500 million tons per year. Swamps, wetlands, landfills, fossil fuel extraction, rice paddies, livestock, termites, everything. Dinosaur farts alone may have equalled or exceeded the entire modern total. Dr. Wilkinson told reporters that he was expecting a number like that produced by cows, so the size of the number really surprised him. He said it is way, way, way ahead of the estimated methane production by modern livestock. That is a direct quote from a peer-reviewed scientist. If that number surprises you as much as it surprised Dr. Wilkinson, hit subscribe. Later in this video, I'm going to show you a completely different study that approaches the same math from the opposite direction. What happened when the farts stopped? Now, to be fair, the researchers acknowledged that their model required several assumptions. We do not have dinosaur gut bacteria samples. We do not have fossilized flatulence detectors. We cannot be certain exactly how sauropod digestion worked, but we can make educated guesses based on the evidence we do have. And every piece of evidence points in the same direction. Sauropods were gas factories. Here is why. Sauropods had a digestion problem. Their teeth were completely wrong for the job they needed to do. Look at a cow's skull and you will see broad, flat teeth designed for grinding. Cows chew their food. They chew it, swallow it, bring it back up, and chew it again. This is called rumination, and it is why they are called ruminants. The mechanical grinding breaks plant fibers into smaller pieces before the bacteria get involved. Now look at a sauropod skull. Those teeth were not designed for grinding. They were designed for grabbing, plucking, and stripping vegetation. Sauropods did not chew. They could not chew. Their jaw anatomy did not support it. This means that when a sauropod swallowed a mouthful of ferns or conifers or whatever prehistoric salad was on the menu, that plant material went into the stomach basically intact. The dinosaur was trusting its gut bacteria to do 100% of the breakdown work. Scientists who study sauropod digestion describe these animals as, and I want you to appreciate this phrase, giant ambulatory fermentation chambers. Walking fermentation tanks. That is what they were. A 2011 study by Jürgen Hummel and Markus Klaus at the University of Zurich examined how different digestive strategies affect methane output. They found that hindgut fermenters, animals that do most of their bacterial digestion in the large intestine rather than the stomach, tend to produce more methane than foregut fermenters like cows. Sauropods were almost certainly hindgut fermenters. Their body plan suggests it, their lack of chewing ability demands it. And hindgut fermentation is less efficient at extracting nutrients, which means the animal needs to eat more food to get the same energy. More food in means more gas out. So you have an animal the size of a building eating constantly because its digestion is inefficient, unable to chew so the bacteria have to work overtime, and using a fermentation strategy that maximizes methane production. The 520 million tons estimate starts to make sense. But there is one detail that might disappoint you, or might not, depending on how committed you are to the word in the title. Most of that methane probably did not come out as farts. In modern ruminants, about 80 to 90% of methane exits through the mouth. It comes up as burps, not down as farts. The digestive system produces the gas in the gut, but the primary exit route is back up through the esophagus. Sauropods were not ruminants, so the ratio might have been different, but the physics of gas production suggests that a significant portion of their methane output was probably ructation. That is the scientific term for burping. So technically, this video should be called "Scientists Published a Paper on Dinosaur Burps." But we both know that does not have the same energy. The science does not care which end we focus on. The point is that sauropods were producing enormous quantities of methane, and that methane was entering the atmosphere, and that methane is a greenhouse gas roughly 80 times more potent than carbon dioxide over a 20-year period. If the Wilkinson team's estimates are even close to correct, sauropod gas was a significant factor in maintaining the warm, wet climate of the Mesozoic era. The age of dinosaurs was hot, much hotter than today, and part of that heat may have come from the largest animals that ever walked the earth, doing what all animals do after they eat. Now here is where the story gets even stranger. 2 years before Wilkinson published his dinosaur paper, a different team of scientists published a study that approached the same question from the opposite direction. Dr. Felisa Smith, a paleoecologist at the University of New Mexico, was not studying dinosaurs. She was studying the Icy Age. Specifically, she was studying what happened when the large mammals of the Pleistocene went extinct. About 13,400 years ago, North America was home to mammoths, mastodons, giant ground sloths, camels, horses, and dozens of other large herbivore species. Within about 1,000 years, most of them were gone. Humans arrived and the megafauna disappeared. This is one of the most dramatic extinction events in the geological record. Dr. Smith wanted to know what effect this extinction had on atmospheric methane. She used ice cores from Greenland which preserved tiny air bubbles from thousands of years ago. By analysing these bubbles, scientists can measure what the atmosphere was like at specific points in history. What she found was striking. Atmospheric methane levels dropped significantly right around the time the megafauna went extinct. The decline was sharp. It was fast. and it matched the extinction timeline almost perfectly. The paper, published in the journal Nature Geoscience in 2010, estimated that the loss of large herbivores removed roughly 10 million tons of methane per year from the atmosphere. That might sound small compared to the dinosaur numbers, but context matters. Atmospheric methane concentrations during the late Pleistocene were much lower than they are today, about 1/3 of current levels, so removing 10 million tons from a smaller pool had a proportionally larger effect. Her analysis suggested that the missing mammal methane accounted for at least 12% of the methane decline seen in the ice cores, possibly as much as 100%. The paper proposed that this contributed to a period of rapid cooling called the Younger Dryas. Starting around 12,900 years ago, temperatures in parts of the northern hemisphere dropped by 4 to 8 degrees Celsius. This cold snap lasted over 1,000 years. The Younger Dryas has always been a bit of a climate mystery. Various theories have been proposed to explain it, including asteroid impacts and meltwater disruption of ocean currents. Dr. Smith's paper added another possibility. The farts stopped, the planet cooled. That is the reverse proof I mentioned earlier. 2 studies, opposite directions, same conclusion. If you want more weird science like this, subscribe. New videos every week. Now let us talk about what this actually means for understanding Earth's climate history. We now have 2 peer-reviewed studies showing that animal flatulence can measurably affect global atmospheric composition. One study shows that dinosaurs may have pumped enough methane into the air to influence Mesozoic warmth. The other shows that when Ice Age mammals died off, the loss of their methane contributed to cooling. Animal gas is not a joke variable. It is a real climate factor with real papers in real journals by real scientists who presumably had to explain to their families what they were working on at Thanksgiving. And here is the part that makes modern humans relevant to this story. After we killed the mammoths, we eventually invented agriculture. We domesticated cattle. We built industrial-scale livestock operations. Modern cows now produce roughly what mammoths used to produce. We replaced wild megafauna methane with domestic megafauna methane, but cows are smaller than mammoths, and there were more species of large herbivores in the Pleistocene than we have replaced with livestock. Dr. Smith's research suggests that total methane from wild animals before human impact may have been higher than what domestic animals produce today. We might actually be in a planetary fart deficit compared to pre-human conditions. I want to be careful here. This does not mean livestock methane is not a concern. It is. Modern agricultural methane is a significant contributor to current greenhouse gas totals, and reducing it is part of serious climate policy discussions. But it does mean that the relationship between large animals and atmospheric methane has been going on for hundreds of millions of years. This is not a new phenomenon. This is how Earth's atmosphere has always worked. And now, in 2024, there is an experiment underway in Siberia to test whether bringing back large grazers can actually affect the climate. Pleistocene Park is a nature reserve in northeastern Russia founded by a scientist named Sergei Zimov. His idea is to restore the mammoth steppe ecosystem by reintroducing large herbivores that were wiped out at the end of the Ice Age. The park currently has bison, musk oxen, horses, yaks and reindeer roaming across about 160 square kilometers. Eventually, Zimov hopes to add more species. There is even a biotechnology company trying to resurrect woolly mammoths by editing elephant DNA. Their stated goal is to produce mammoth-elephant hybrids that could eventually be released into places like Pleistocene Park. Zimov's hypothesis is not primarily about methane, it is about permafrost. Arctic permafrost contains vast amounts of carbon from frozen plant material. If that permafrost thaws due to climate change, the carbon will decompose and release greenhouse gases, potentially creating a feedback loop that accelerates warming. During the Pleistocene, large herds of grazing animals trampled the snow, exposing the frozen ground to cold winter air. Snow is actually an insulator. Without it, the ground gets colder. Zimov believes that restoring large grazing herds could help keep permafrost frozen for longer, even as climate change progresses. Initial data from Pleistocene Park suggests the effect is real. Ground temperatures in grazed areas are measurably colder than in areas without large animals, so we have come full circle. Scientists calculate dinosaur farts and discover they may have warmed the Mesozoic. Other scientists calculate mammoth farts and discover their absence may have cooled the Pleistocene. And now, a Russian scientist is trying to bring back grazing animals to cool the Arctic. Animal gas and animal behaviour are climate variables. Legitimate ones, with papers. The Wilkinson dinosaur paper has been cited over 100 times in other scientific publications. It is not a joke study that got buried. Other researchers have built on it, criticised it, refined its methods and engaged with its conclusions seriously. Markus Klaus, a digestive physiologist at the University of Zurich, who was not involved in the original study, noted that the calculations were based on mammals and reptiles rather than birds, which are the closest living relatives of dinosaurs. If herbivorous birds produce less methane than similar-sized mammals, the sauropod numbers might need to be revised downward. But even with conservative estimates, the basic conclusion holds. Animals that large, eating that much vegetation for that long, would have produced enormous amounts of methane. And there is one more detail from the research that deserves mention. We do not actually know for certain that sauropods had methane-producing gut bacteria. The assumption is reasonable because every large modern herbivore relies on microbial fermentation, and the physics of digesting cellulose basically requires it, but we have no direct fossil evidence of sauropod gut flora. Uncertain Dr. Wilkinson acknowledged this uncertainty. He told reporters that without a time machine you cannot be sure. Time machine, which is true of most paleontology. We are reconstructing the past from fragments and inference. The dinosaur fart calculations are speculative. They are scientifically informed speculation, educated guessing based on physics, biology, and the available evidence. And that is how science works. You build models, you make predictions, you see if the predictions match the data. The Mesozoic was warm, sauropods existed, sauropods probably farted. The math suggests the farts could have mattered. It is not proof, but it is a reasonable hypothesis published in a top journal and taken seriously by other researchers. Which brings us back to where we started. In 2012, 3 scientists calculated dinosaur fart output and got a number so large they did not believe their own math. Their paper proposed that sauropod flatulence was a measurable factor in the climate of a 150 million year era. 150 million. 2 years earlier, different scientists showed that when Ice Age mammals went extinct, atmospheric methane dropped faster than at any point in a million years of records. Methane. And right now, in Siberia, a scientist is trying to reverse the damage by bringing back large grazers. Siberia. The science of animal gas is real. It is peer-reviewed. It has implications for understanding both the deep past and the uncertain future. And it all started because someone asked a question that sounded like a joke. How much gas came out of dinosaurs? 520 million tons per year, roughly equal to all modern sources combined. That is what they found.